Hello student, good morning to all. In previous lecture, started instruction set. First instruction, group of instruction. There are 5 group of instruction. Started the data transfer instruction. Okay. In previous lecture, we see the move MVI instruction, LDA, LXI, LHLD. These are the data transfer instruction. Now, in this lecture, we see the remaining data transfer instruction. Okay. First is a STA instruction. Okay. So the STA is instruction store accumulator direct. Store accumulator direct. The content of accumulator are copied into the memory location specified by the operand. For example, if accumulator contain 25 hex, then after executing this instruction, see the example STA 2500 hex. Okay. So after then executing this instruction, STA instruction, it will copy 25. This 25 is copy in the memory location 2500 hex. So the after execution, this memory location 2500 hex memory location stored 25 hex. Okay, so this 25 is stored in this memory location. Okay. Now we see next instruction, that is STAX instruction. In this STAX register addressing, STAX instruction, the content of accumulator is STAX, that is the stored accumulator indirect. Stored accumulator indirect. Okay. So the content of accumulator are copied into the memory location specified by the content of register pair. Content of register pair. This instruction is a 3-byte instruction. Okay. So see, firstly we see the example. Example STAXB. This B term, B is a register pair BC. Okay. B means BC register pair act as a pointer. Okay. The B means BC register pair act as a pointer. If accumulator contain 8 E hex, okay, and register B contain 17 hex, and register C contain 70 hex. Okay. After executing this instruction, this BC 17 and 70. So after executing this instruction, the memory location specified by the content of register pairs. The memory location is 1770 hex. It's the memory location specified the content of this register pair, that is the B and C. So after execution, this accumulator content data 8E stored in 1770 memory location. So 8E stored here. Okay, got it. Now next instruction is XCHG. This instruction exchange the HL with DE. The content of register H are exchanged with register D, and the content of register N exchanged with the content of register E. Okay. For example, XCHG. Okay. And use before execution, H contains 17 hex and L contain 20 hex. After executing this instruction, D equal to 70 hex and E contain 20 hex. Okay. So H are exchanged with D. H are exchanged with D. And L are exchanged with content of register E. And before execution, this D contain 20 hex and E contain 23 hex. Okay. So using this exchange instruction, H exchange with D and this L exchange with E. So here L equals to 23 and E equals to 20. Here H exchange with D. So D contains 17 hex and here H contains 20 hex. Okay, got it? Using the exchange instruction. Now, after that, we see the next group of instruction, that is arithmetic instructions. Arithmetic instruction. All we are know about what is the arithmetic. Okay, this instruction perform operation like addition, subtraction, then increment and decrement. Increment and decrement. These are the performed by arithmetic instructions. Okay. So first we see the addition. Any 8-bit number or content of register or the content of memory location can be added to the content of accumulator. See, in the addition, any 8-bit number or the content of register or the content of memory location can be added to the content of accumulator. Okay, the result stored in accumulator. Here in addition, result stored in accumulator. Okay, and no two other 8-bit register can be added directly. Okay. Here we are not used any two register or two other 8-bit register are not added directly using the addition instruction. Okay, for example, the content of register B cannot be added with content of register C directly. Okay, for example, if we use add B, is register B added to the content of accumulator. Here, the content of register B cannot be added directly to the content of other register. Okay. Now, I started and after that, see the subtraction. Same here. Any 8-bit data or content of register or the content of memory location can be subtracted from content of accumulator. Same here in subtraction, result is stored in accumulator. Result कहाँ पे store होगा? Accumulator में. Okay. So subtraction is performed in 2's complement form. In previous 11th standard, we already learned 1's complement, 2's complement. Okay. So the subtraction performed in 2's complement form. If the result is negative, it stored the 2's complement form. Okay. Same like addition, no two other 8-bit register can be subtracted directly here. Okay. No. Then increment or decrement. Increment or decrement, 8-bit content of register memory location can be incremented or decremented. Okay. The 16-bit content of register pair can be incremented or decremented by 1. Here, increment or decrement can be performed on any register or memory location. Any register or memory location. Here, using the increment or decrement instruction, incremented or decremented by 1. The 16-bit content of register pair can be incremented or decremented by 1. Yeah, or increment or decrement can be performed on any register or memory location. So next we started our instruction, that is arithmetic instruction. So arithmetic instruction, first instruction is the add instruction. Add instruction. Add R. Use a small letter here. Add R, add M. Add register or memory to accumulator. Yeah. Add register to accumulator. Here, add memory to accumulator. Okay. So in this instruction, the content of register or memory are added to the content of accumulator. If the operand is memory location, see here, if the operand is a memory location, its address specified in HL register pair. Okay. Using this instruction, all flags are affected or all flags are modified to reflect the result of addition. Okay. For example, add B. Okay. So the before execution, accumulator contain 11 and register B contain 10. The after execution result, that is the result stored in accumulator. Result stored in accumulator. So the accumulator contain 21. Okay. Here in arithmetic instruction, and use the BCD numbers. How to write? Here A equals to 11 and B 10. 0, 0, 0, 1. You already see here in a addition, any 8-bit number or content of register or content of memory location can be added to the content of accumulator. Okay. So see here, 8-bit number 0, 0, 0, 1, B 0, 0, 0, 1, 0, 0, 0, 2. Previous year in 11th standard, we see the rules of addition and subtraction. Okay. So in addition rule, 1 plus 1 equals to 1, 0. 1 plus 0 equals to 1. Here 1 plus 1, 0, and carry 1. Here 1 plus 0, 0 plus 1, result is 1, and 0 plus 0, result is 0. Okay. So 1 plus 0, 1, 0, 0, 0, 1, 1, 0, carry 1. Here 1 plus 0 plus 0, 1, 0, 0. So this number is 2, 1. So accumulator contain 21 here using this add instruction. Okay. Say add m. If you using add m, yeah, memory location say accumulator content 21 and this memory location 2050 hex, and this 2050 hex memory location stored in HL register pair 20 and 15. This memory location stored the 10 hex. So after execution, accumulator contain 21 hex. Okay, got it? How to solve the add instruction? Using the add instruction, all flags are affected. All of you know about the flag. In 8085, there are 5 active flags. Okay, how to set the flag here using this instruction? First, 7 bit is 0. Okay, 7 bit is 0. So sign flag set to 0. Result is non-zero. So that's why 0 flag set to 0. Okay. Then auxiliary carry flag. Here D1, D2, D3, D4, D5, D6, D7, D0, D1, D2, D3, D4, D5, D6, and D7. In auxiliary carry flag, if D3 to D4 carry is generated, that time auxiliary carry flag set to 1, otherwise it's set. Here, no any carry is generated from D3 bit, so auxiliary carry flag set to 0 here. Then parity flag, count the ones, 1, 2, that is A2 is an even number, so parity flag set to 1, and carry flag set to 0. After D7 bit, if carry is generated, that time carry flag set to 1, otherwise reset. Here, no any carry generated after D7 bit. So carry flag set to 0. Okay, all flag are modified using the add instruction. Okay. Now we see the next instruction. Next instruction is the ADC register or ADC memory. The content of register or memory and carry flag and carry are added to the content of accumulator. Okay, the result stored in accumulator. In this instruction also result stored in accumulator. Okay, if the operand is memory location, its address stored in HL register pair. All flags are affected using this instruction. For example, A, B, C, B. Okay, A, D, C, B. Before execution, accumulator contain 12 hex and register B contain 10 hex. So after execution, accumulator contain 22 hex here, but ADC with carry. See here, carry. If carry is 0, 1. So accumulator contain 23 hex. Okay, accumulator contain 23 hex. How to solve this instruction? Using the BCD number A equals to 0001 0010, that is 2. Then register B is 0001 0000 here, and carry equals to, okay, so here 1 1 0 0 1 1 0, carry 1 1 is here 0 0. Okay, so here 2 3, so 23 stored in accumulator. 23 stored in accumulator. Same using the memory location M. So the address specified in HL register pair F2050 address is this address stored in HL register pair, and this memory location contain the 10 hex and accumulator contain 12 hex. Similarly, accumulator contain 23 hex using this same instruction. Okay, got it? Now we see the next instruction. Okay. I'm again repeating this instruction ADCR. This instruction is add register to accumulator with carry and add memory to accumulator with carry. Okay. Now we see the next instruction, that is ADI. ADI instruction. Here ADI 8-bit data. So this instruction add immediate to accumulate. Add immediate to accumulate. In this instruction, which addressing mode is used here? Immediate addressing mode is used. The 8-bit data is added to the content of the accumulator. Okay. Same here. Result stored in accumulator. All flags are affected. This instruction is a 1 byte instruction. For example, ADI 45 hex. So this 45 immediately stored in accumulator. This data 45 immediately stored in accumulator after the execution. Okay. Now we see the next instruction, that is ACI instruction. Add immediate to accumulator with carry. ACI instruction. Okay. Same example here. ACI, add immediate to accumulator with carry. Similar to ADI instruction, ACI, here add immediate to accumulator with carry. Okay, so this 45 hex plus carry, that is 0 1, and result is 46. This 46 stored in accumulator. Okay, this 46 stored in accumulator after this executing this instruction. Okay, after executing this instruction, in this instruction 8-bit data and the carry flag, 8-bit data and the carry flag are added to the content of accumulator. Okay, so here accumulator content 0 1, yeah, and 45 stored in here. So we see the result. Data 45 hex, then accumulator 0 1 hex and carry flag 0 1 hex. So 47 hex, the result stored in accumulator. This 47 hex result stored in accumulator in this instruction. Data added to the content of accumulator with carry. Okay, got it? Now see the next instruction, that is a DAD instruction. DAD, DAD instruction. This DAD instruction operand is a register pair. Add register pair to HL pair. To HL pair. Using this instruction, 16-bit content of register pair are added to the content of HL register pair. The result stored in HL pair. Here, result stored in HL pair. Okay. If the result is larger than 16-bit, then carry is set. After executing this instruction, if the result is larger than 16-bit, that time carry is set. Carry flag is set. No other flag are changed using this instruction. Okay. Only carry flag is set when the result is larger than 16-bit. No other flag are changed using this instruction. This DAD DAD B. Okay. So this is B. Denote here BC register pair. Okay. Now see the next instruction, that is a subtraction. Subtraction instruction. Okay. So in subtraction, any 8-bit number or content of register or the content of memory location can be subtracted from content of accumulator. In subtraction, result is stored in accumulator. Subtraction is performed by 2's complement. Subtraction is performed in 2's complement form. Keep in your mind, if the result is negative, it is stored in 2's complement form. Okay. In subtraction, 2 register are not subtract directly here, like addition. No 2 other 8-bit register can be subtracted directly. Okay. The previous year we see the 1's complement and 2's complement also. Okay. We again revise this concept in our next lecture. 2's complement, 1's complement, 2's complement. Okay. Then we started the subtraction instruction, that is SUB sub. Okay. We see in our next lecture. Okay. So we will stop here. Thank you, students.